Hello and welcome to edupediaworld.com. After going through the short run laws of production, let's start with the long run laws of production. But before starting, let's revise that what is the difference between short run production and long run production. As studied earlier, short run is a time period in which at least one resource is fixed. Like we have done in the last session, we assumed that capital to be a fixed source of production and labor is variable input of production. Well, how long is the period of short run or long run is, I would say it depends. Let me explain this through with the help of an example. Let's say you have decided to open a restaurant and you have done your homework and you know that most of the restaurant failed within the first year. So being cautious, you decide to sign a lease for just 6 months. So in this case, because you're signing a lease for 6 months, so your building, that is the place which you have rented, will be fixed for 6 months. So short run here would be 6 months. Now suppose if you decide to sign a lease for at least 2 years, so in this particular case, the premises would be fixed for 2 years. That is, at least one factor of production is fixed for 2 years. So short run here would be 2 years. Now suppose you, after the expiry of the lease, you decide to increase your premises, or you decide to continue with the lease, in fact extend the lease, or you decide to downsize the place, the premises required for running your restaurant. So after the 2 years has expired, when all the factors of production can be changed, that time period becomes long run. We have already dealt with the short run laws of production. Now we'll be starting with long run, where all factors of production can change or become variable. So in the long run, supply of both the inputs, that is labor and capital, is considered to be elastic, and firms can hire larger quantities of both labor and capital. The technological relationship between changing scales of inputs and output is explained under the laws of returns to scale. The law of returns to scale can be well explained through production function and Isoquant curve. We'll be first starting with Isoquant curve. So what is Isoquant curve? Isoquant is a word which is derived from a Greek word where iso means equal and quantus means quantity. So we also called Isoquant curve as equal product curve, production indifference curve, and what does this curve shows? Basically, Isoquant curve shows that at any point on this curve, it is a combination of labor and capital which will always produce the same unit of output. So an Isoquant curve is the locus of points, that is, it is the combination of points representing various combinations of two inputs, and here are two inputs, is one is labor and the other is capital. yielding the same output. And what are the assumptions of Isoquant curve? First one, there are only two inputs as labor and capital to produce a commodity, and both the inputs we consider it as variable because it is a long run. Both L and K and product X are perfectly divisible. That is because we consider it as a long run, both are variable, so we can divide each and every factor of production. The next assumption, the two inputs L and K can substitute each other but at a diminishing rate as they are imperfect substitutes. See, if they would have been perfect substitutes to each other, and suppose we take the labor on x-axis and capital on y-axis. So if they would have been perfect substitutes, then the curve would have been a straight line, which shows that 1 unit of capital replaces 1 unit of labor. Similarly, 2 units of capital replaces 2 units of labor. But this is not the case. The curve, the isoquant curve, is always like this, which shows that 1 unit of labor cannot replace 1 unit of capital. There are more or there are less units required in order to replace the given units of labor. Next assumption is that technology of production is given. That is, the technology of production will not change. It is constant in nature. Let's see through a schedule that how do we get the same locus of points. We get four combination on a particular curve, that is A, B and C and D, and these combinations are a point which we get by combining labor and capital. When we take OK4 plus OL1, the output which we get is 100. Then when we take OK3 and OL2, the output which we get again is 100. So we can see that on all the combinations of point AB and ABC and D, we get the same unit of output. And we can also see that as and on we are increasing the units of capital, we are decreasing on the units of labor. See, when we are using 4 units of capital, we are using 1 unit of labor. When we are using 3 units of capital, when we have decreased the units of capital, we have increased the units of labor. Similarly, as and on we are going on decreasing the units of capital, we are increasing on the units of labor. And then by this combination, we get points which are A, B, C and D, and which gives us the output always equal to 100. Now let's see that how do we represent it graphically. On x-axis we take labor, on y-axis we take capital, which is represented by K. 1, 2, 3, 4 units of labor, and likewise we take capital 1, 2, 3, 4 units of capital. So when I use 4 units of capital, I use 1 unit of labor, and the output which is produced by this combination is 100. Again, when I use 3 units of capital, I use 2 units of labor, and the output again which is produced by this combination will be 100. Similarly, 2 units of capital and 3 units of labor, output is 100. 1 unit of capital and 4 units of labor, output will be 100. So if we combine these 4 points, we get a curve like this: A, B, C, and D. So this is our isoquant curve where we get equal quantity produced by using a combination of labor and capital, and that is 100. So this is how we make a isoquant curve. Let's go through the properties of the isoquant curve. The first property says isoquants have a negative slope. We can very well see here in this diagram, in this graph, that the isoquant curve is sloping negatively towards its right. Now why does this happens? This happens because as and on we go on increasing the units of capital, we have to decrease the units of labor. So there is a negative relationship between the capital and labor, or we can say there is an inverse relationship between capital and labor. That is why this curve is sloping negatively towards its right. If there would have been a positive relationship, then the curve would have been like this. But that is, as and on we are increasing capital, we are also increasing upon the labor. But in this curve, we would have never got the same units, the quantity produced, because as and on we increase all the factors of production, the quantity produced is bound to increase. So that is why the curve is negatively sloping. The next property is isoquants are convex to the origin. Now what does that means? It means that you can see here, this is the curve. We'll draw the curve again. This is the isoquant curve and it is convex to the origin. Now this property we can denote two reasons behind this factor, this particular property, that it is convex to the origin. That is substitution effect, and the other reason is the marginal rate of substitution between the inputs is diminishing in nature. See, as we have already seen that because labor and capital are not perfect substitutes to each other, as well as the marginal rate of substitution is diminishing in nature. What is MRTS? MRTS can be calculated by change in capital, that is decrease in capital, divided by change in labor. Now this MRTS basically denotes the slope of the isoquant curve. This denotes the slope of the isoquant curve, and we can see because it is negatively sloping towards its right, so it's the marginal rate of substitution is diminishing in nature. As and on we go on substituting labor for capital or for capital for labor, the it the rate of substitution goes on diminishing, that is decreasing. The next property is isoquants are non-intersecting and non-tangential. Let's see how. If I draw a isoquant curve here, Suppose this is isochron curve, which where at any point on the isochron curve we get the same quantity produced, that is 100. Suppose if I have to draw another isochron curve, it will never be a tangent to the earlier curve. Suppose it denotes 50 units. It won't ever be like this, that it won't be a tangent to the earlier isochron curve. It will either be below or above, but never touching the edge of the previous isochron curve. Likewise, one isochron curve never intersects the other isochron curve. Suppose this is an isochron curve which denotes 100 units of quantity produced. The other isochron curve will never be like this. If this isochron curve has to denote 200 units of quantity produced, it won't be ever like this, that it won't intersect the earlier isochron curve. It will again be always upper to this curve or below this curve. It actually shows that higher units of capital and higher units of labor quantity gives us higher units of output. Similarly, lower units of capital and lower units of labor quantity gives us lower quantity produced. So they will never be tangent or cutting each other. The last property of isochron curve is that upper isochorns represent higher level of output. This means that suppose if I draw an isochron curve here, on x-axis again I show the labor, and on y-axis I show capital. So if I draw one isochron curve like this and the other isochron curve, this is isochron curve 1 which denotes 100 units of output produced, and this is the other isochron curve which denotes 200 units of output produced. So the upper isochron curve will always show higher units of output produced and lower isochron curve will always show lower units of output produced, because here in this particular curve, in this IQ1, the units of capital used is the same at this particular point, but the units of labor used is less as compared to the units of labor used in IQ2. We can see here, if I am using OL1 unit of labor, I am using OL2 unit of labor in the upper isochron curve. So we can see here that the upper isochron curve will always denote higher units of output, because one or the either factor of production we use more quantity as compared to the lower one. Lower isochron curve represent lower unit of production and upper isochron curve represent higher unit of production. So these were the various properties of isochron curve. That is, isochorns have a negative slope, isochorns are convex to the origin, isochorns are non-intersecting and non-tangential. Upper isochorns represent higher level of output. Now with the help of isochron curve, we will in the next session study about the long run law of production, that is law of returns to. Thank you for watching Edupedia. We'll continue in the next session.